stable system produces bounded input for the bounded output. The denominator of the polynomial is called characteristic equation, and the roots of the characteristic equation are called poles. And based on the location of the poles on the plane of the stability of the system can be classified into stable, unstable, and marginal. There are two methods to find the stability analysis. First is Routh-Hurwitz and the second is Locus.
First we will be seeing about Routh-Hurwitz. Routh-Hurwitz is used to find the stability of the control system. So under this we will be having a polynomial which is an equation. Under that we will be having characteristic equation. So with that characteristic equation we should find the roots. We should find how many roots are present. So through that roots we will be able to plot the graph where the roots are placed in left half of the plane, right of the half of the plane, or the imaginary axis. Through this graph, we'll be able to find whether the system is stable, unstable, or marginally stable. There's a condition in this Routh-Hurwitz. The first column of the Routh-Hurwitz should be positive. If the first row is negative, then the system is said to be unstable.
The benefit of using Routh-Hurwitz is helps determine the stability of the system by checking the number of sign changes in the first column. Here you can see that, and it is a quick calculation. But it provides a fastest way to check the system stability without calculating the entire equation. In other method, we have to calculate the entire characteristic equation, but we no need to do entire equation, and less complex. It is simple and less time consuming compared to other stable methods like root solving methods, and we can able to identify the instability also by how many poles lies in the right half of the S-line. Benefit, here we have disadvantages too. So here we cannot able to find the exact roots. If only shows the stability, does not give the exact values of the system's poles. Okay, so if a row becomes entirely zero, if the row becomes entirely zero, the method fails. We need special handling method to find the correct roots.
So the second method is Routh-Locus. It is a graphical representation to understand the performance of the system by varying one parameter from 0 to infinity. To construct a Routh-Locus, there is 6 steps. First step, to locate the poles and zeros. Second step, to find the Routh-Locus on real axis. Third step, to find the angle of asymptotes and centroids. Step 4, to find the breakaway and break-in points. Step 5. Step 5 is to find the angle of departure and angle of arrival. It is only for if the root has complex numbers. Next, step 6. Find the crossing point on imaginary axis.
Some of the advantages of Routh-Locus are you can find the stability of the system from Routh-Locus. Phase margin and phase margin can be determined from the Routh-Locus. Performance of the system can be predicted to Routh-Locus. You can find the roots of the characteristic equation using angular and particle conditions, and it is easy to determine. And some of the disadvantages of Routh-Locus are Routh-Locus technique can be applied only to linear systems and linear time invariant systems, and it is not suitable for discrete time systems, and it is only useful to analyze the closed loop system.
To conclude that, Routh-Hurwitz provides a straightforward way to determine system stability, and Routh-Locus helps visualize how stability and system response change with controller turning. In real-world application like vehicle suspension system, these methods are used to ensure stability, safety, and performance.